let's try to solve this problem here. You have coherent light with wavelength of 400 nanometer passes through two very narrow slits that are separated by 0.200 millimeter, and the interference pattern is observed on the screen 4 meter from the slits. Okay, so if you want to represent the situation, we can probably sketch something like this. We have a double slit, and I'm going to draw a center line so that we know where's the central bright later, and this will be where we find our screen. Okay, so I'll label this as the slit, and I'll label this as my screen. So right now they say that you have light of 400 nanometer coherent passes through two very narrow slits. So okay, let's say today this is your light. Your light comes in like plane wave, okay, incidenting on this slit over here. So you can probably write down their wavelength. Their wavelength right now is 400 nanometers, so 400 times 10 to the power of 9. Okay, it's good to convert it into standard form, or in this kind of times 10 to the power, because later student might forget that there's a nano over there. They need to convert it to times 10 to the power negative 9. So it's good that we label it first. Okay, next, they say that it passed through two very narrow slits that are separated by 0.200 millimeter. So this is the distance between one slit from the second slit. So this is what we call as the small d. Okay, this is the distance between the two slits. So the distance between the two slits over here is small d. So small d is 0.200 because it's millimeter. So times 10 to the power negative 3 meter. Okay, then next, and the interference pattern is observed on the screen 4 meter away from the slits. So from the slit, you move 4 meter away, that's where you see your screen. So that is actually the distance between the slit and the screen, and we are going to call it as D is equals to, big D is equals to 4 meter. Okay, now they are asking what is the width in millimeter of the central interference maximum. So if you are talking about interference maximum here means by they are looking for bright. So they are looking for which bright? Central. So that means they are asking for the width of the central bright. Width of the central bright. That's question A. For question B, they ask what is the width of the first order bright fringe. So it might be another fringe, it might be the same fringe. Let's try to figure it out which fringe are they looking for the width. Okay, because only asking for the central and the first order, we don't need to draw until 5 or 6 fringes. Let's probably draw the first 1 or 2 or 3. That will be enough. Okay, so let me label. Okay, I'm gonna draw one side of it only because yeah, usually don't analyze so many sides. Okay, sorry for asymmetrical kind of bright and dark. Okay, so basically that's what you can observe. You are supposed to draw it on the other side as well, but usually I just draw it on one side because I'm analyzing on one side. Okay, so they ask what is the width of the central bright. Central bright is very clear. When we are talking about central bright, this is the fringe that we are referring to. We are looking for its width. If you are looking for its width, then it's right in between this dark and this dark over here. So we can say the width of central will be here. This is W central. Okay, next they ask for the width of the first order bright fringe. If you look at the word order here, immediately you should think that this value here is M. So because it's first, so that means it's M is equals to 1. So M is equals to 1. If you're talking about interference of double slit, the equation for bright is Y is equals to M lambda D over D. But we have to think carefully whether M can start with 0 or not. If you substitute 0 inside, your M will be 0, then your Y will be equals to 0. That means that Y is equals to 0, it's a bright fringe. Is Y equals to 0 a bright fringe? Yes, at the center, it is indeed a bright fringe. So that means that M is equals to 0 here is a valid value to substitute. That means that if you start with 0, followed by plus minus 1, plus minus 2, plus minus 3, and so on and so on. Okay, so now that we know that the m will start with 0, that means by your central here we start with m is equals to 0. Then the next one will be m is equals to 1. The next one will be m is equals to 2. So now they're asking for the first order breadth fringe. First order breadth fringe is m is equals to 1. That means by they are interested with this particular fringe over here. So if you want to find the width of this fringe, it will be right in between this dark and this dark over here. So this is the width of m is equals to 1. Okay, but of course we know that our equation is all about y. Okay, if you're talking about bright, then this is y is equals to m lambda over d, m lambda d over d. If we talk about dark, then the equation will be y is equals to m plus half lambda d over d. Okay, where your m will start from 0 also, maybe plus minus 1, plus minus 2, plus minus 3, and so on. Okay, so now we have the equation for bright and dark. Well, we need to determine the y first, and from the y we can determine the w, which is the width over here. Okay, anything must always be measured from the center, so I'm going to draw the center line to be longer. Okay, so what can we do to determine the width of the central? Maybe we can measure from the central to the first dot that we can see over here, because this is where our width of central stop, right? So if you measure this distance here is where we find the first dark, and for first dark over here, the m should also start with 0. Your m start with 0 for this dark equation as well. So the first dark that we see, it will be m is equals to 0 as well. So this will be m is equals to 1. So because this is m is equals to 0, what are you finding here is actually y 0. Okay, let me put it in green. Okay, be consistent. If you talk about width central, I put it in green. So this one will be y0 dark. Okay, this one will be y0 dark. And how do we relate this y0 dark here to w central? Well, we can see that another side is also the first dark or the 0th order dark, right? So if you measure from the center downwards to this point, you should also find that this value here is y0 dark. Okay, so essentially what I'm trying to say here is the width of a central is actually 2 times the y0 dark. So we can make an equation for question A. We can know that the width of central is actually just 2 times of y0 dark. Okay, how about question B? For question B, what is the width of the first order breadth fringe? They're asking for this yellow fringe here. What's the width? Well, for this one, you know that it will be related to this dark over here, which is the second dark or the first order dark. So we are going to measure from the center again. We are going to pull up to where you find the second dark or the first order dark. So this value here will be y1 dark. And if you take this y1 dark over here, you minus with y0 dark over here, the difference between y1 dark and y0 dark will give you the width of the first order breadth fringe. So for the second question, for question B, to determine the width of the first order, you'll be just taking y1 dark minus y0 dark. Okay, so now that we have figured out the relationship between the width and the y, the distance from the central, right, what we can do is just substitution right now. Okay, I'm going to start by solving the question A first. So this will be 2 dark. The equation for dark is plus half. That's a plus half. So this is 0 plus half lambda d over d. Okay, so if I do my calculation, 2 times half is 1. So equation will now become lambda d over d. So substitute lambda is 400 times 10 to the power negative 9. Distance between slit and screen, it's 4 meter. Then your small d, distance between slit, will be 0.2 mm. Okay. So you substitute in everything. If you do your calculation, I believe you get your width of your central to be equals to 8 times 10 to the power negative 3 meter, which if you convert into millimeter, it will be 8 millimeter. Okay, why do you convert to millimeter? Because that's what the question asks for. Okay, for question B, you want to find the width of the first order. You take y1 dark minus y0 dark. So y1 dark, it's 1 plus half lambda d, lambda big D over small d. Y0 dark is 0 plus half lambda big D over small d. So if you want to simplify the equation, we can factorize out the lambda d over d. So this will be lambda d over d. Then what's left on the outside bracket, inside bracket is 1 plus half minus 0 plus half, minus 0 minus half, which will cancel out the half. Then we are left with 1 minus 0, which is 1. So essentially equation is left with lambda d over d over d. So again, you're going to substitute a similar thing. 400 times 10 to the power negative 9, 4 meter. Distance between the slit will be 0.2 mm. So if it's 0.2 mm, then you can find the width 1 over here, actually to be having the same answer as the width central, because the substitution are the same. So you get the answer to be equals to 8 times 10 to the power negative 3 meter, which is also 8 mm. Okay, so this is consistent with what we learned from the theory, in which all the bright fringe or all the dark fringe, they should have the same width. The width of all the fringes are the same when we are talking about interference of transmitted light through double slits. So that's it for this question over here. Thank you very much.